of structural analysis. Okay, so before going for solving the different for before going to solve the to have the review of different methods of structural analysis, one must know that why there is a need to solve the members by using the different methods of structural analysis. Okay, now whenever we are talking for the structural analysis, there are two basic concepts. One is your design concept and another one is your analysis concept. So for designing, you must have the various values which are going to use in your design purpose. That is your forces, stresses, axial forces, and the other components like the moments at the joints, at the supports, at the midspan, and everywhere. So, what is your structure? Structure is basically an assemblage of number of types of components like slabs, beams, columns, walls, foundation, and which will remain in equilibrium all the time. So, if all the members are satisfying the fundamental criteria of strength, stiffness, economy, durability, compatibility, then it is in a equilibrium condition. So, basically, your structure has been divided into two types, that is statically determinate structure and statically indeterminate structure. Indeterminate structures are also called as your redundant structures. Now, what is the need to find out the determinacy of a structure? To clarify the concept regarding to its stability, that whether your component of member or your structure is stable or not. If you know its static determinacy, then you will conclude that whether a structure is stable or not. Okay, so there are basically two types of structural design analysis in civil engineering, that are your statically determinate and statically indeterminate structure. So I will try to make difference between the statically determinate and indeterminate structure. Now, your most common type of common structure in your day-to-day life is your residential building. Now, residential building is a statically indeterminate structure. In order to understand the indeterminate structure, first we have to analyze the statically determinate structure. Okay, so statically determinate structures are the structures which can be analyzed by using three equilibrium equations. That is your summation of x or horizontal forces equals to 0, summation of vertical forces equals to 0, and summation of moments are equals to 0. If your structure is being analyzed, if your member is being analyzed by using three basic equilibrium conditions only, then your structural member and or then your structure is known as your statically determinate structure. Okay, but along with these basic equilibrium condition, if some extra conditions are required to use the but if you require extra conditions to solve these structural component like compatibility equations, deformations, to draw the bending moment or shear force diagram, then these structures will come to know statically indeterminate structures. Okay, now determinate structures are simply your simply supported beam, cantilevers beam, then overhanging beams. These all beams will come under your determinate structure. Indeterminate structures are your fixed beams, continuous beams, arches, then multi-story building, frames, uh, then portal frames, etc. Now see, just assume one beam, okay, and if supposed to be your in that beam your A point or support A is hinge support and support B is your roller support. Okay, so In this beam, the reaction occur at A is vertically upward as it is a roller support, and in a horizontal direction if it is a hinge support. And at B there is only a roller support, hence there will be only a one reaction, that will be a vertical reaction. Okay. So in this beam, total three unknowns reactions are there. Two reactions at support A, which is hinge, and one reaction at support B, which is roller. So this beam can be analyzed with the whole help of three equilibrium condition only. Okay. So if the number of unknown reactions are less than or equal to the equilibrium reactions, that is 3, then structure can be easily analyzed, and this structure is known as a statically determinate structure. Okay. So analyzing is to calculate the shear force bending moment of the structure. Now take one more example. Now in this beam, if your both the ends are your hinge support, okay, so if your support A is again a hinge support and your support B is also a hinge support. So at A you are having a two reaction. One is vertical reaction, another one will be your horizontal reaction. And at B again you will be having a two reaction. One will be your vertical and another one will be your horizontal. Is it? So we cannot analyze this structure or beam because these type of structures are known as indeterminate structure, because here total number of unknowns are 4, which is greater than the equilibrium equation, and equilibrium equations are only 3. So to solve this type of structures we need different types of method, and this beam will be termed as a statically indeterminate structure. Okay. Again, if you see in residential building, then all the members like beam, column, slabs are fixed with each other. So they have definitely more unknown reaction than the equilibrium equations, which is 3. Hence, there are statically indeterminate structures. Okay. So, indeterminacy of the structure can be defined as if your equilibrium conditions are not the only conditions by which you can solve your given member or structural component, then that will be termed as your indeterminate structure. Okay. A statically indeterminate structure is again classified as your externally indeterminate and internally indeterminate structure. Now externally indeterminate structure is your beam, frame, and your internally indeterminate structures are your trusses and frames. Okay, so we'll go with the externally indeterminate structure. Externally indeterminate structures or redundant structures are called if the reaction at the support cannot be determined by using three equilibrium equations only. In case of beam subjected to vertical load only, two reactions can be determined by conditions of equilibrium. Okay, so in the case of beam, you are having only a vertical reactions. So in that case, your internal redundancy is 0. So beam will be considered as an externally indeterminate structure. Okay. So simply supported cantilever or overhanging beam are statically determinate structure. See here, in this simply supported beam, just before we had taken one example. Here, your two reactions at A and B will be your two vertical reactions, is it? And your unknown, your equilibrium equations are summation of fx equals to 0, summation of fy equals to 0, and summation of moment equals to 0. Here we are having two unknowns, we are having three equilibrium equations. It means you can solve this beam, simply supported beam, by means of equilibrium conditions only, hence it is indeterminate structure. Okay. Again, if you will take an cantilever beam, in cantilever beam at hinge support, you are having the three unknown reactions. So we are again having three equilibrium conditions. So again, 3 minus 3 will give you 0 unknown. Okay, after using three equilibrium conditions. So 3 unknown, 3 equations, it is compatible. So again, the cantilever will be considered as your determinate structure. So there are so many types of method by means of which we can solve our indeterminate structures that we'll see in later classes, like strain energy method, moment distribution method, three moment theorem, then slope reflection, moment distribution, then column analogy method. So in then externally, after externally determinate structure, there are internally indeterminate structure. Then in truss, if statically determinate internally, if the total number of members will be m is equals to 2j minus 3. Okay, if a truss member will satisfy this condition, that is m is equals to 2j minus 3, then that truss will be considered as your stable truss or a stable member. If your number of members are less than your 2j minus 3, then it will be considered as your unstable member. Okay, so and if your m will be greater than 2j minus 3, then that will be considered as your indeterminate structure, and then we have to proceed for the different method for solving that indeterminate stress element. Now here see, unknown are 4 and we are having 3 basic equations. So here it is a stable but indeterminate stress. Again it is a stable but indeterminate stress. We have seen that statically determinate structure is a structure for which reaction at support and internal forces in the member can be found out by the continuous by the conditions of static equilibrium. Okay, and example of determinate structure are here: simply supported beams, cantilever beams, single and double overhanging beam, three hinge arches, etc. Okay, then how to find out the degree of indeterminacy, that is either it is internal indeterminacy and external indeterminacy. Okay, if you have to find out the internal indeterminacy of the structure, then that can be found out by using that total number of unknowns minus the equilibrium conditions. Okay, if supposed to be in a beam, you are having, just see, we will go with this example. Okay, so your total static indeterminacy will be calculated as your summation of total external indeterminacy plus total internal indeterminacy. Okay, so external indeterminacy can be calculated as your number of reactions minus the three equilibrium conditions, and internal indeterminacy can be calculated by using the formula or by using the element for which we are calculating the indeterminacy. Okay, if suppose we will go with this example. Okay, so observe this figure. So here your indeterminacy can be calculated as total number of reactions minus the equilibrium condition. Okay, now here, as it is a beam, for beam your internal indeterminacy is 0, because in beam you will deal with the only moments and the wait. Okay, in beam elements we will deal with the only two types of forces or two types of uh, structural forces, that one is your force and another will be your moments. Okay, and we are having three equilibrium conditions. Okay, so your beam can be analyzed by using the equilibrium condition internally. That is why internal indeterminacy of beam is equals to 0. So for this case, that it is a beam, your static indeterminacy will be your total number of reaction minus the number of conditions available. Okay, so here total number of reactions will be 3 at fixed, 3 at another fixed, and 1 will be your ruler. So here 3 plus 1 plus 3 will be your 7 minus your number of conditions or number of equations available are your 6, that is one is your roller, another one is your pin, and there are 3 reactions. So it is your 6. So 7 minus 6 will going to give you 1. So here the degree of indeterminacy is 1. So now we are familiar with that what is determinate and what are the indeterminate structures. Okay, so we'll just take quick review or the quick difference between determinate and indeterminate structure. Determinate structures are the structures which can be fully analyzed or solved by using the equilibrium conditions. Then indeterminate structures are the structures which cannot be solved by using the equilibrium conditions. Okay. Then all the material properties will be will not cause any change in the bending moment and shear force of the in the determinate structure, and material property will definitely cause changes in the bending moment and shear force in case of indeterminate structure. Bending moments or shear force at any section is independent of the cross section or moment of inertia in case of determinate structure, but in case of indeterminate it is the dependent of the cross section. Again, temperature variation will not cause any changes in the stresses or forces in indeterminate structure, but in determinate structure, but in indeterminate structure the temperature variation will cause change in the stresses. Again, lack of feed will not make any changes in the stresses in determinate structures, but in indeterminate structures there will be change in the stresses if it is a short of feed or lack of feed. Then as it is a determinate structure, there is no need of other types of conditions like compatibility, displacement, superposition, etc. In indeterminate structure, there is a need of extra conditions like compatibility, displacement for analyzing the member or structure. Okay. Then next component or next structural element after beam is your truss element. Okay. Now, what is truss element? As we know, truss elements are nothing but the structures or a member which is composed of links or bar assumed to be connected by frictionless pin. And again, all members of truss lie in one plane, so that will be called as your plane truss. And if the truss members will lie in the three-dimensional or more than one plane, then it will be termed as your space truss. Okay, either if it is a plane truss or it will be a space truss, but the loads will be applied at joints only. There will be no member load. So these are simply a triangulation members to make the stabilized structure. Triangulation is the stable configuration. Mathematically, we can call it as a truss. Has a member called the top chord, bottom chord, and a vertical chord. Or either you may have the diagonal chord. Now, what are the functions of truss element? Truss element carrying the load from over the structure. Again, they provide the adequate lateral stability to the entire structure. While designing or making the construction of truss, there are basic assumptions which will clarify the construction of truss and confirm with the design assumptions to avoid the unwanted failure due to the conjunction of forces in the truss elements. The very first assumption is truss members will carry only the axial loads or the axial forces. Again, the nodes or the connections or the joints of the members are designed as a pin joint, that is your hinge joint, so that moment won't be transferred to the member of the truss. All the external loads and the reactions will act on the nodes only, and because there is no member force or there is no member load, and your truss should be in a plane. Members of truss are made up of I sections, T sections, tube sections, square section, or either can be of channel sections. There can be simple truss, or you may call it as a plain truss, that is planar truss, or a space truss. Okay, then we'll go through the next topic, that is your principle of superposition. Now, simple principle of superposition says that, or it is basically used to solve your complex problems with multiple loads or reactions acting on the member. So in that case, superposition method will help us to solve these problems by breaking a member into many, breaking the members down as necessary for each force acting on it. Once all our stresses or deflection for that point of uh, interest are found, they can be added all together to get the final answer. Okay. So what is simply a superposition theorem? It is the principle of superposition simply states that on a linear elastic structure, the combined effect of several loads acting simultaneously is equal to the algebraic sum of effect of each load acting individually. That is, we can cut it down into a number of pieces or number of elements, and that we can solve each element individually by using individual load or getting an individual stresses, forces, change in length, everything. And once we will get uh, different values for that section, then we can again sum up all the values to get the final output or the final answer for that member. If supposed to be you are having a beam, and on that beam if supposed to be a loading is given, and that loading can be split into a simple type of two different loading. If again I am having a beam having a UDL and a point load, so I can split that into a simple beam and load. Okay, my first beam will be a beam with a distributed load, that is a UDL, and another beam can be with the beam of having a point load only. So I can solve first beam by the method of load having the UDL and another beam having only the point load. So there are two conditions in which a structure must satisfy in order for the principle to be valid, and that two conditions are that your structure should be linearly elastic structure. Okay. The equation of equilibrium must be based on the undeformed shape of the structure. If size of the deformation occurring to the structure are smaller enough to be considered negligible. Okay, so there will be negligible deformations. For using the principle of superposition. Then second assumption is the material used in structure must be linearly elastic. In order for a material to be considered this way, its stress-strain relationship must relate to the Hooke's law. Okay, that is the law of elasticity. Now observe this figure. Here, one load is given P1 at half the section, that is, it is acting at a distance of L by 2. And again, another load of P2 acting at a distance of L from the A point. Okay, so the total deformation will be the deformation causing because of P1 and the total deformation causing because of P2. Okay, so we have two methods. One, you can solve all the deformation togetherly, and at the end you will get the final output. Else, by using the principle of superposition or the superposition theorem, you can split this cantilever beam or cantilever member into the two sections. First section will be your having a load P1 acting at a distance of L2. You will solve first this one. Okay, just observe this solution. Now see here, we have to find out the total change in length causing because of the load P1, causing because of the load P and the R. Okay, so once we will find out the change in length causing because of the load P acting at a distance of L1, that is PL by A. Next you will find out the change in length causing because of the load RC, that is the again RL by A. Okay, so from first figure, because of the equilibrium, total summation of forces must be equal to the 0. Okay, so you will find out the reaction from here. Then by applying the superposition principle or principle of superposition, apply the condition for that. That is change in length for load P and change in length for load C must be equal to the 0. So what will happen for this case? You can split this beam into two cases, that is first change in length will be caused because of the load P1 and second change in length will cause because of the load P2 acting at a distance of L from the extreme left side. Okay, so the final change in length will be your P1 L by A plus P2 L by A. For first case your L will be L by 2. For second case your L will be L by for second case your L will be length will be L. Okay, so when we will sum up these two change in lengths, you will get your final change in length. Okay, so we have started our trusses. So there are two types of trusses. Those are your perfect trusses and imperfect trusses. A trust will be called as your perfect trust if your number of members will be equals to 2j minus r, where j is your number of join, r is your number of reaction. Okay. It is called as your imperfect trust if your number of members are not equals to your 2j minus r. Okay. Here it should be not equals to m is not equals to 2j minus r in case of imperfect trusses. Okay. If again imperfect trusses can be classified into two types, that is the deficient truss and the redundant truss. Redundant is nothing but your indeterminate and deficient is nothing but your unstable. So if your number of members are lesser than the 2j minus r, then your structure is unstable structure or it is a deficient structure which cannot be built practically. Then another type of imperfect truss is a redundant stress, which is having number of members greater than 2j minus r. Okay, so these are the stable trusses which we have to find out by using the different methods of compatibility and deformation, because here three equilibrium conditions are not the only satisfied for solving the truss element forces. One thing, let me clear over here. If we are saying that our structure is either statically determinate or statically indeterminate, that will not actually give rise to the condition for the stability, that whether your structure is stable or not. Okay, whether it is stable or not, that will be your practical approach. On the, whether it is determinate or indeterminate is nothing but your structural approach. That by either you can solve this, you can analyze this structural component by using the equilibrium condition or not. This is the only case or this is the only condition for determinacy. But when we are talking for the structural stability, then you have to check the many cases, that either again one of the tests will be your it is determinate or not. Another one you have to see the practical approach. It's supposed to be I will say if a beam is having only parallel forces, okay, it is having only parallel forces, then definitely it will be an unstable beam. Okay, there should be parallel forces but having different magnitude. Again, if you are having a collinear forces or a concurrent forces, then concurrent forces will meet at a same joint, same point. Again, that will be an unstable condition. So there are various types of condition that can leads to a structural instability, that will definitely depends on the practical approach, that how your member your structure will going to behave when it will be put up into the structure. Okay, so instability and indeterminacy, these two are the different concepts. Just observe this figure. A figure showing a two-dimensional plane truss. Okay, so it is having 16 number of members, 9 number of joints. Then total number of unknown reactions are 4 and total number of equilibrium equations will be your 3 because it is a 2D truss. If it is a 3D or space truss, then total number of reactions will be 6 number of reactions, 3 moments and 3 reactions. Okay, so here degree of static indeterminacy externally will be your unknown reactions minus the equilibrium condition. So unknown reactions are 2 at hinge, 1 at roller, again 1 at roller, that is 4 minus number of reactions or the equilibrium equations, that is 3. So 4 minus 3 will be a 1, that is degree of static indeterminacy externally. Then internal indeterminacy will be calculated with the formula m plus r minus 2j. So m is your 16, r is 3 minus 2j. So this will give rise to your 1. So your total indeterminacy of this plane truss will be your external indeterminacy plus internal indeterminacy, that is your 2. Okay. So it is 2 degree or second degree indeterminate structure. So I think everyone is now okay with the determinate structure and indeterminate structure, or you have the basic idea regarding the determinate structures and the indeterminate structures. Okay, so we will go with the types of trusses. Like, there are basically two types of trusses, that those are the perfect and imperfect trusses. Okay, a truss member is called as perfect truss if its number of members are equals to the number of joints minus r, that is 2j minus r. If this condition is satisfied in the truss, then that truss member will be termed as your perfect truss member. And then your truss is called as imperfect truss if this condition is not satisfied. That is, if your number of members are not equals to 2j minus r, then your truss member is called as imperfect truss. Then their imperfect trusses are again classified into two types of trusses. Those are yours deficient and redundant. Deficient trusses, if your number of elements are less than 2j minus r, then it will be a deficient truss. And if your number of elements are greater than twice j minus r, that is, it is a indeterminate structure or the redundant structure. Then there are few methods to solve these trusses, either plane trusses or space trusses. These methods are termed as your method of joint and method of section. Okay. All the members of truss should have the straight connected to each other at their ends by frictionless pin and no external forces acting in between their joints. Identifies each truss member as a two force member which may be in a tension or compression. Okay, in truss elements we know it is a pin jointed, it will only have an axial force, it will not have a member force. Again, the joint between the truss will be frictionless. Okay, so your first method to solve the truss is method of joint. In method of joint, what we do, for truss we consider the free body diagram for the entire truss element. Okay, if your truss element is having unknown reactions, then first we have to find out the support reactions. Once you will find out the support reaction, then we have to consider the free body diagram FBD of the joint from the truss at which we do not have more than two members with unknown force exist. Okay, because it is a pin jointed truss, so we have only two number of equations by which you can solve the truss joint. That is your summation of vertical force equals to 0, that is summation of y equals to 0, and summation of fx equals to 0. That is summation of horizontal forces equals to 0. Okay, so you have to find out a joint at which we are not having more than two members, or having two more than two unknowns at that joint. Okay, we have to assume that either the force in the member will be in tension or compression by simply inspecting or by simply assuming the tension member or compression member. Okay, then once you have selected that joint which is not having more than two unknowns, apply two basic equilibrium condition, then find out the unknown over that joint. Okay, once you have done with the first joint, then select second joint. Again, that joint must have only two unknown reaction and move on. This process should be continued until and unless you are having the force in the final member of that truss element. Okay, just read out this. While using the method of joint to calculate the forces in the member of truss, the equilibrium equation are applied to the individual joints of the truss. Consequent, two independent equilibrium equations are available. That is your summation of forces in x direction equals to 0 and summation of forces in y equals to 0. Okay, here few thumb rules I have written, that by which you can directly find out that whether this member is a zero member or a equal force member. Okay, so these are only the thumb rule. If you are not okay with that, just go with the simply solving the all joints and you will get the final answer or the final forces in that particular member. Okay, see if any joint is identified without external force acting on it, such that joint is formed by three members and two of them are collinear, then the third non-collinear member should be identified as zero force member. Okay, if at a joint there are three members who are collinear having the same magnitude of forces, then third one should be a zero force member. Okay, again if any joint is formed by a non-collinear members without any external force acting on it, then both the members are identified as zero force member. If there are two members without any external force, then there will be zero force in both the members. Again, if any joint is formed such that only four forces are acting and non and are collinear in a pair, then each collinear force is equal. Okay, four forces are there in two collinear branches or two collinear laterals, and both the laterals should have the equal magnitude of the force. If a given truss is symmetrical, then you have to solve half of the truss element. Remaining half of the truss element will be having the same forces like a mirror image of that truss element. Okay, but in this case, the truss element should be perfectly symmetric. Then your second method to solve the truss element is your method of section. Okay. For solving the truss element with the method of section, it's supposed to be you have to find out the force in only one element or in one lateral only. In that case, choose divide your section or truss in such a way that you will put that truss into two parts, that one part should not have more than three unknowns at a time. Okay. So select the cutting section to cut the truss into two parts such that it should not cut more than the three unknown members. Select the free body diagram of any one of the two parts considering all internal and external forces acting on that part. Assume the tension or compression in the cut member and applying equilibrium condition its numerical values can be obtained. If the obtained value is negative, do the required change in the nature of force. Okay, if you have assumed that force tensile, then you have to convert its sign to the compressive because you are getting a negative value. Okay, so why to use the section method is supposed to be you have to find out the force in particular one lateral or one member only. Okay, so in that case you have to solve the whole truss member by the joint method. But by the use of section method, you can directly find out or you can cut the truss element and you can find out the force in that member only. Okay, so in section method we do not have to analyze the entire truss. If any intermediate member force is desired to be obtained, it can directly be obtained by selecting proper position of section, so it is less time consuming as compared to your joint method. Now after truss, the next element is your beam element. Okay, so beam is your horizontal flexural member which is primarily uh, built to resist the load coming from the slab level and to counteract the bending coming again from the external or the uh, superior loadings. Okay, there are three types of beams. Those are your simply supported, overhanging, cantilever types of beam. Again, fixed types of beams. Okay, you may just go by reading over this. We will directly go with the yes. Now There are so many types of method to analyze the structure, especially the beam member. Each of these have its own advantage and disadvantages and can be used based on the type of beam, load conditions, and the degree of accuracy required. Some of the most commonly used methods are your slope deflection method, Carney's method, integration, matrix method, displacement method, then moment distribution method. Then again, software methods are there, and few uh, empirical methods are again there, like column analogy method is there. Then there is a rigid frame method. So we'll see one by one in coming classes. Then there are cables. Cables are often used in your engineering structure to support and to transmit load from one member to another member. Okay, everyone has seen cables. कहाँ पे देखे होंगे हमने cables? Transmission cables are there. Then there the cables are in bridges, then in flyovers. At Ramchula, it is a suspension type of bridge, is it? You may have seen cable over there. Okay. So a cable subjected to a concentrated load. Just look at this figure. We will quickly solve this cable problem. Okay, see here your cable is connected with two support at both the ends, and it is subjected to two load at joint C and at joint D. Okay. So just convert this into a free body diagram. Here it is having a hinge at A and a hinge at B. So replace both the hinge by the reactions. Okay. Now I have applied a summation of moment at A is equals to 0. I have to analyze this cable. Simply I have to find out the various forces into the various elements of this cable. Okay. So by applying summation of moment at A is equals to 0, I got my value as TCD, this force, as your 6.79 kilonewton. Okay, because you know this B force, you know this C force. Okay, you are applying summation of moment at A, so forces at A will become 0, so you will directly get your TCD. Okay, then apply summation of Fx equals to 0, Fy is equals to 0 at for this structural component, then you will get your force at A. Here see, summation of forces in horizontal direction is equals to 0, and summation of forces in summation of forces in vertical y direction is equals to 0. By applying these two conditions, you will get your angle, then you will get your force in P and angle as 53.8 degree. And your height for this element is again coming out as 2.74 meter. Then there is one more type of bridge, that is your cable stayed bridge. Just read this example. Again, you have to find out the tension in the cable at point A, B, C, and weight of this girder is given, that is 850 pounds per feet. Okay. So here are few formulas which we can directly use. Now to find out the height, we have a formula, that is W0 by 2FH into X square. Okay. We are given with the total height of 40 feet and a height at C point is 20 feet. Okay. So from C to A it will be 20 feet. So at center I had assumed this length from B to C as horizontal length as X. So my total length is 100. So from A to B my horizontal length will be 100 minus X. Okay. X dash. So just put this value in here in this formula. From A to C your vertical height is 20 feet. Then your total weight is 850 by twice ch into x square. Okay, so you will get your fh that is your horizontal force. Then again you will apply this for the total height, that is for 40 feet. So you will get your values for the tension in that cable, that is at B and at C. Okay. Then I have included few question answer type questions here, that how many methods are there to use the to solve the structural member. So there are so many methods, few are written over there. Then what are the general steps of the consistency of deformation method? We will take this structural method. So just leave this. The next question is here, give example of beam of 1 degree static indeterminacy. Okay. So see here, your one joint is fixed joint and your another joint is roller joint. So fixed joint is having three unknowns. The roller joint is having one unknown. So total number of unknowns are 4 minus, you are having 3 basic equilibrium equation. So 4 minus 3 will be your 1. Okay. There is one more term, that is your kinematic indeterminacy. This is your static indeterminacy and one is your kinematic indeterminacy. So kinematic indeterminacy is nothing but your degree of freedom, that how many degrees are there that by which your joint can rotate. Like if I take example of door. Okay, door is the best example of hinge support, is it? It can rotate only, it we cannot lift upward, or it will not move in the vertical y direction or the horizontal x direction. Okay, it will rotate about the z direction only. So it is having a degree of freedom as 1 or kinematic indeterminacy as 1. So what will be your indeterminacy, kinematic indeterminacy? It is defined as the least number of independent displacement required to deform to define the deformed shape of structure. So there are again two types of degrees of freedom, that is the joint type and the nodal type. Then we have seen the external redundancy and internal redundancy. So in pin joint frames, redundancy caused by too many members is called the internal redundancy. Then there is external redundancy caused by too many supports. Okay, the redundancy caused by the members will be your internal redundancy, and when it will cause because of the external loading or the external support, then it will be considered as your external redundancy. Okay. Then why to provide redundant member? Now redundant is nothing but your indeterminate. Now practically it is very much difficult to provide the determinate structure only, because in a space at a single node, at a single joint, you are having 6 degrees of freedom. Okay, at one joint 3 3 degrees of freedom for the displacement and 3 degrees of freedom for the moments. Okay, so at single node you are having 6 degrees of freedom in space. If you are considering a single block, in block you are having 8 number of nodes. So 8 into 6, that is 48 degrees of freedom. So DOKI, that is degree of kinematic indeterminacy for a single block having 8 number of nodes will be of 48. Is it? So it is practically impossible to provide the redundant structure. So to maintain the alignment of two member, then to increase the stability, then to maintain stability during the loading, to provide the support if applied loading is changed, then analyze the and analysis is difficult but possible for the indeterminate structure. Now, if I'm saying that if you are considering a single room, you are having 8 nodes. So you cannot solve that 8 nodes, that is 48 number of unknowns. In 48, if supposed to be you have applied fixed joint on all the four corners. Okay, so 4 into 3, that is 12 number of unknowns will be deleted. So 48 minus 12, that is 36 will be unknown. So you cannot solve 36 number of unknowns by using the various methods. Okay, you will see few methods, but by those methods you can solve your your indeterminacy if it is 3 or maximum up to level of 4. Okay, but if you are having more than 4 unknowns, so in that case you cannot solve those all practical problems manually. We may solve, but it is actually too difficult or too tedious. So for that case we have to use different analyzing softwares like statpro, ansys, sap, etap, and again there are so many. So what are the various methods? Then finite element method is there, FEA is there, then flexibility matrix method is there, and there is a stiffness matrix method. Stiffness matrix method is nothing but your matrix method. Then what are the statically indeterminate structures? Statically indeterminate structure we have seen already. Okay. Define consistent deformation method. Then primary structures. Then write the formulas for degree of indeterminacy. Yes, this is quite important. In competitive examinations, you are given with the elements and you have to find out the degree of indeterminacy. Okay, if you have to find out the static indeterminacy, then there will be directly formula. By using these formulas, you can directly find out the indeterminacy. Okay, in these formulas, your M is number of member, R is number of reaction, and G is number of joint. Then what is the effect of temperature on the member of a statically determinate structure? Okay, we have already seen difference between determinate and indeterminate structure. When we are talking for determinate structure, there is no such change. Then there is change in temperature, either change in length of the members. That is either it is a lack of heat or short of heat. Again, if you are having rise in temperature or fall in temperature, it will not cause, or these would not result in internal stresses or the change in external reactions. But in case of determinate structure only, okay, here it is the question is for plain truss, but it is applicable for all the structural elements. But when you are talking for indeterminate structure, that in those cases your temperature and the changes in the member length will going to have changes in the final stresses or the final forces of that element. Okay. Then define internal and external indeterminacy. Internal indeterminacy is the excess number of internal forces present in the member, while the external indeterminacy is the extra number of forces or extra number of reactions causing because of the support reactions. Okay, so internal indeterminacy is always because of the member, wherein your external indeterminacy is always because of your supports or the joint supports. Okay, by which you will find out the unknown reactions. Okay, for the beam element, your internal indeterminacy will be 0. Okay, again your indeterminacy in the case of beam will be find out only basis on the external indeterminacy. That is nothing but your unknown reactions minus the equilibrium conditions. So you will directly get your DS, that is degree of indeterminacy. Okay. So tomorrow we will deal with the few methods to solving structural analysis problems like beam, truss, frame. So there are 2 to 3 methods have been included over here. So we'll see जितनी cover होती है उतनी करेंगे. Okay. Again, one more thing. Here, observe this figure. It is a plain 2D truss. Okay. See here. only you are having the nodal joints. There are no forces. So in this case what will happen, you can find out the reaction only, and if supposed to be you have to find out the forces in, you observe the figure number B and figure number C. Okay, so you can solve these two stresses by means of sorry uh, uh, stress B you can solve by means of joint method only, because again दिखने में ये सिमेट्रिक लग रहा है, but it is not symmetric, because on the one hand you are having hinge support and on the another hand you are having a roller support. Okay, if the supports are same, then only it will be your symmetrical geometry, but here your supports are different, so it will be considered as your asymmetric figure. So you have to solve this stress member by using method of joint only. Okay, in figure number C, in truss C, here it is a geometric structure because no joints are there. So okay, so for the present situation I can say that it is a symmetrical. So here you can solve this by using the method of section. Okay, if I will again keep a support over there and two different supports, then again it will be not considered as your geometrically similar or the identical mirror image type of truss. Okay, so be cautious as using the section method or by applying the but for solving by applying the forces and the stresses of first half to the another half. Okay, it is not the identical when you cut down the stress into the two halves. Okay, thank you.